terminal velocity and drag force in air. In my short video, you have seen about the terminal velocity and the drag force. But now I will tell you that how to find the expression for the terminal velocity from the drag force in the air. As I have told you in the video that terminal velocity is the maximum velocity attained by the body which falls vertically downward in the air. This is the definition of the terminal velocity. The maximum velocity attained by body falling vertically downward in air is called terminal velocity. Terminal velocity denoted by Vt. This is the definition of the terminal velocity. After attaining the terminal velocity, the acceleration of the body is zero, because terminal velocity is the constant velocity. Beyond that, the velocity does not increase. Terminal velocity is maximum constant velocity. Constant velocity. तो constant velocity है तो acceleration तो इसका जीरो होगा ही होगा. So now acceleration dvt upon dt, this is equal to 0. This is what the acceleration, that is equal to 0. When the body falls vertically downward in air, its velocity increases due to gravitational force of Earth. So now this velocity goes on increasing till it is balanced. So at the same time, there is a drag force that acts on the body. The drag force due to air comes into play, and it opposes the velocity of the body. It means that as soon as this drag force will start to act, the velocity, that this force will oppose the velocity of the object. It means that this will act opposite to the gravitational force. So now I tell you about this drag force, FD, drag force. FD is equal to minus 1 by 2 C A rho into V square. This is the formula of this drag force, where C, this minus sign shows that this FD is always opposite to the velocity. So the angle between this drag force and the velocity is equal to 180 degree. So angle between FD and V equal to 180 degree or pi radian. This minus sign shows that this is the opposing force. Where C, this is equal to drag coefficient, and this drag coefficient is different for the different body. It depends upon the shape of the body. For the spherical body, this C is equal to approximate 0.45. For different bodies, the value of C is different. Drag force which depends upon the shape of the body. Shape of the body. And this now A, this is now cross sectional area of the body perpendicular to the velocity. To the velocity. Suppose the object is falling like this, then this surface area, that will be the cross-sectional area. So this will be counted. Suppose a spherical body is falling, then the surface area is equal to 4 pi r square. So that surface area will be counted. So this surface area is perpendicular to the velocity of the body. Rho, density of air, and V the velocity. V the velocity of the body. As you are looking from here, that this Fd is proportional to the square of the velocity. It means that if suppose velocity is doubled, then this drag force will be 4 times. So as the velocity increases, this drag force increases. So this is what, that this velocity is more effective in case of drag force. So this drag force depends upon these 3 factors. Now what happens to this terminal velocity that I saw by the diagram? Now let this is the body. This is the initial stage that I am showing to you here. This is now weight empty. Now when the body is somewhat like this position, then this drag force comes into play. This is now weight mg. This is now fd. And when this object is in this condition, this is now weight mg, and this is now drag force fd. So now what you are looking from here? In the first case, only the gravitational force is acting. Because of that, its velocity increases continuously. As this drag force comes into play, then this opposes the velocity. I have shown by these arrows. This arrow is smaller than this one. It means that this drag force is smaller than the weight. In this stage, this arrow is equal to the arrow of this mg. It means that this drag force is equal to the weight of the body. Now in this stage, the body attains the terminal velocity. So this is now accelerated. In this situation, is still accelerated. And in this condition, no acceleration. Acceleration, this is equal to 0. So in this condition, both are equal. So this is what that I have shown you like this. As the body goes down, then after some time, the body attains the terminal velocity. So in this, there is no acceleration at all. So here the body attains the terminal velocity. So now what will happen? That these two forces will be equal to 0. So now the sum of these two will be equal to 0. Now here only the drag force is, only the weight is acting, and in this condition F is less than FD is less than mg, और यहाँ पर दोनों क्या होते हैं? बराबर हो जाते हैं. So net force F is equal to mg minus fd. This is not net force. Now when this force is equal to 0, when F equal to 0, it means what? In equilibrium. equilibrium has reached. So this net force is equal to 0. So now what we will have that this mg minus fd, this is equal to 0. So now in this stage, this mg is equal to fd, and now as we have in this stage, the velocity will be equal to the terminal velocity. The body attains terminal velocity. It means what? That is V is equal to Vt. So now this mg is equal to 1 by 2 C A rho into Vt square. This is what the Vt square. So now this Vt equal to 2 mg upon C A rho. This is the formula for the terminal velocity. Now this will be no square root. So this is the formula. It is the formula for terminal velocity. Velocity in air. So now you can see that this terminal velocity depends upon the mass, the gravitational acceleration, the drag coefficient, the cross-sectional area, the density of the medium. So depending on all these, you can see that as the m is more and more, it means the heavier the body, more will be the velocity. This is why that very heavy body, when they are falling in the atmosphere, they get the high terminal velocity. And for smaller bodies, this Bt is very small. So there are so many examples of this terminal velocity, like your drops, the water drops or the raindrops falling in the atmosphere. So this is about the terminal velocity and the drag force in the air. So thank you very much.